So starting with section 2, one question, why do elements in the same group have similar properties? It is all about electrons in this chapter. So the reason group 1 is very reactive is because they have how many valence electrons? 1. Group 2 is almost as reactive. It has how many electrons? 2. Group 8, not reactive. It has 8. It's full. So full is stable and full is non-reactive. Other than helium, helium only has 2 because it only has an s orbital. It does not have a p orbital. So based on configurations, what are the 4 blocks? And then review, look at vocabulary. This is an easy section. So not too bad. This is your first slide, right? Okay. So recall, electrons in the highest principal energy level are called valence electrons, called outside electrons, outer electrons. Everything in group 1 or 1A has 1 valence electron. So if I look at hydrogen, which is in group 1, all of these are in group 1. Hydrogen ends with 1s1, so 1 valence electron. Lithium ends with 2s1, 1 valence electron. First period, second period, third period, fourth period, they're all in group 1. They all end with 1 valence electron. So if I look at even their dot diagrams, it's even easier. Do notice that I'm pulling out the transition metals. Transition metals do not follow this rule. So group 1 all have 1 valence electron. Group 2 has 2, 3, 4, 5, 6, 7, 8. Remember in last section that the rule of 8 or octaves? 8 is full. 8 is stable. So in order to be stable, something has to be full. And the only group that is full is group 8 or 18, your noble gases. And that's why they don't react with anything. So group 2 have 2, 13 through 18 is 10 less than their number. So the periodic table that I've given you with the colors, it has 13, 14, right? And then does it have 3A, 4A, 5A? Yep. So 13 minus 10 gives me 3, or it's 3A, it's one of your representative groups. The energy level of an element's electrons indicates what period they're in. So this ends with 1s1. 2s1, it's in period 2. 6s1, it's in period 6. This will end with 6s2 because it's in group 2. So here's the blocks. Here's my s block. Remember, s has 1 orbital, 2 electrons. So here's where the electrons can go. And notice helium is up in that s block because there's only 2. Here is my p block. So this is p1, p2, p3, p4, p5, p6. P has 3 orbitals. It can hold 6 electrons. So here, if I'm looking at boron, it's in what period?
1,
2. Because hydrogen and helium are the only ones in period 1. So this will end with 2p1, 2p2, 2p3, 2p4. If I count down 1, 2, 3, 4, 5, if I look at this row, this will end with 5p1, 5p2, p3, p4, p5, p6. The middle are my D blocks. How many electrons does D hold? 10. 5 orbitals, 10 electrons, so D1, D2, 4, 5, 6, 7, 8, 9, 10. The only difference is, here's 1, 2, 3, 4. This is 3D1. You subtract a level. This is my 4Ds, these are my 5Ds, and these are my 6Ds. Down here I have my F blocks. How many electrons in F? 14. And here again, now I'm going to subtract. This is your 4F1, 4F2, and these are, so you only have 2. You have 4 Fs and 5 Fs.
Shouldn't the top one be 5 and the bottom one be 6?
Yeah, that's what you said last time.
No, it changed.
Are you sure? It should be 4 because there's 3 Ds and there's 4 Fs. If I said 5, then I apologize. I said it wrong. If I did I not correct myself?
No, I have 5 too on mine. Isn't it?
Because this comes right after here, so 5D, 4, this should be 4F. If I said it wrong, I apologize. It should be 4F and 5F. So here they're just kind of going into depth more of what I already talked about. S block consists of group 1 and 2 and helium, because helium only has 2 things. Group 1 elements have a partially filled s orbital, so there's only 1 electron in it, it's not completely full. Group 2 elements have a completely filled s orbital, so they end with s2 because it's totally full. 13 through 18, or 3A through 8A, are your p orbitals. And in group 18, both your s and p are completely full, and that's why they have 8. So my s is full, that gives me 2. My p is full, that gives me 6. It is 8. So if I look at neon, here's my outer energy level, 6, 7, 8. If I look at argon, 6, 7, 8, everything is full if I look at the very end of my periodic table. Interactive table, you can do this on the computer. I'm not going to go over, and that's basically over the table we just looked at anyway. D block, middle, contains the transition metals, and it's the largest block. It contains the most electrons, or the most elements in your periodic table. There are exceptions, but D block elements usually have filled S's and then partially filled D's. So for example, titanium is the one that I had on your test, so we'll look at that. So titanium is in what period?
3, 4.
4. It should be in period 4. So in front of it, my 4s2 is full. So I would have potassium would end with 4s1, calcium would end with 4s2, and then I go to scandium.
Yep.
That would be 3d1. And titanium would be 3d2. And I know I used that one on. So it's not full. If D is full, it would be what?
Or
10. D can hold 10. So if I have 3d10, what element is that?
Zinc.
Zinc. It is zinc. So zinc would end with 3d10. It's at the end of your D block. And there, I would have still, if you look at zinc, how many valence electrons does zinc have? 2. 4 is my biggest number, so it has 2 valence electrons. So 5d orbitals, it can hold 10 electrons. It goes across all your transition metals. F block is your transition metals at the bottom. And here, 4F, 5F, I really apologize if I said that. I totally don't disagree that I did. So, first one is 4, second one is F. 7F orbitals hold 14 electrons, and the inner transition metals span 14 groups. We only look at 4 and 5 at the bottom. We are about done. So, strontium, which is used to produce red fireworks. A lot of your fireworks are based off of colors of different elements. So strontium is a common one, and it produces red. Has a configuration of krypton 5s2. Don't look at your periodic table, heads up. Without looking at your periodic table, what group is it in? 2, because it ends with S2. What period is it in? 5, because the number 5, it tells you what period it's in. And what block is it in? What letter block? S. It's in the S block. So if I want to look for strontium, I will count down 5 rows, and it's in the second block, so should be and is right where it should be. So why do elements have similar properties? Because they have similar valence electrons. They are going to combine with other elements because of that. And based on their configurations, there are S blocks, P, D, and F. So you can use that to figure out configurations much easier.